guys, with the name of God Ram Ram, I am Kumar ki. My student has cracked SD2 offer at PayPal. I am very happy for Salaiman. Guys, today we are going to discuss, apart from the student selection, we are going to discuss the Codechef starters 180 division 2 problems from A to D in a very intuitive manner. So first, let's check the first problem. The name of this problem is operations on array. So guys, they are saying that we are giving you an array of n positive integers and the size of the array is odd. Like anytime you can select any three consecutive numbers and replace their maximum instead of those three numbers, and like this the array will keep on shrinking. And you don't just have to replace with maximum, you have to replace with max of the first number plus one, second number as it is, and third number plus one. So it's a little tricky, okay? So you better be safe, okay? So your task is to determine the maximum possible value of the final remaining element if you perform the operation. So if I try to explain this to you in a simple manner, they are saying that you are given an array of size n is odd, okay? Every time you select I plus 1 and I plus 2 indices and replace it by maximum of this equation. Basically maximum of the three numbers, but the first number and the third number can be added by 1. In each operation, when you do the replacement of three consecutive numbers by one number, which is the max of these three in this format, the size of the array will decrease by 2, guys. Finally, only one element will be left as the size of the array is odd, okay? That final element should be as large as possible. So use your mind and say how to optimally do the operation so the final element is as big as possible. For example, let's take 1, 2, 3. This is the array given to you, right? Now do the operation. This is index I, this is index I plus 1, this is I plus 2. Like you can see like that, right? Because that's what they have given. Yeah, I plus 1 and I plus 2. So if I select this, what is going to happen? I have to replace them by max of these three numbers. Max of 1, comma 2, comma 3, but the first number can be added with the 1 and the last number can also be added with the 1, which is max of 2, comma 2, comma 4, which is 4. So 1, 2, 3 will be converted to 4 and 4 is a single element. 4 is a single element. So guys, 4 is the answer. So like this guys, any array will be given to you and you have to figure out what is the maximum element possible remaining in the end of the procedure. Okay, lovely people. So let's take one more lovely example. So let's say this is your array. You have to select three consecutive elements, right? So let's take these three consecutive elements. What is gonna happen? This will remain like this, but max of 5, comma 2, comma 4 will be 5 only. So 1 and okay, one more thing I forgot to say is that that whatever you are doing, it should the size of the array should be odd, right? So let's take this as 1. So if I do the first operation on these three elements, I will be left with 1, 5, these three elements reduced to 5 and this one as it is. Now if I do operation on this, what is going to happen? Max of 1 plus 1, 2, comma 5, comma 1 plus 1. You know now the first and the last element always you do plus 1, which is 5. So we got 5 as the answer, guys. 5 as the answer. But is there a better way to do this? Was there a better way to do this? Let's think about it. First of all, we did the operation here, then we did the operation on these remaining numbers. You can also feel it and I can also feel it. So 5 is the best answer in this particular category, right? But what if your array was like this? Now what will you do? We need to figure out now where to do these operations. Okay, see it's given here. what will be your strategy, okay, to make element I as the last man standing and make sure element I becomes as large as possible? This is the thought which came in my mind, which solves the whole problem. But before that, how to know where should you do the first operation? Should I do the operation here, or should I do the operation here? Like, the thoughts come in the mind, na, which is optimal. We don't have any proper greedy algorithm here. We don't know what is optimal for the future. Just relax, bro. Just relax. Let's try to do the operation here. This is gonna get replaced by 5. Okay. Then you do the operation on 1 to 5. It will become 6. 6 is the best answer possible. But guys, the way to solve this problem is that you fix any index I. You fix any index I. Let's say I fix this index as I. Now guys, you have to make this guy as the last man standing. Last man standing means till the end the ith guy should not die. When it can happen? You will use all the elements on the right hand sides. So you are just assuming that this guy will always remain and the right hand side guys will die. So what will happen? 4, 3, 2. How many right hand side guys are there? Sir, there are 2 right hand side guys. So 2 by 2, one operation will happen, right? So, this guy is gonna become, they will disappear and our 4 will become 4 plus 1, which is 5. Okay. Then guys, how many elements are there on the left hand side? There are 2 elements. So 2 by 2, one more operation can happen. So these guys, when I do the operation with our element, one more 4 plus 1 can be generated. So basically, these right elements are giving plus 1 effect and this is giving plus 1 effect. So overall effect is 4 plus 1 plus 1, 6. So this element can become as large as 6 if you exhaust all the remaining elements and try to make it the largest element. I will show it to you with one more brilliant example. So let's say this is the index I. You want it to be the last man standing. This guy should not die. So what will you do? How many elements are on the right hand side? On the right hand side, there is only one guy. So no operation can be done directly here. No extra operation can be done. How many guys are here? One, 2, 3, 4, 5. 5 guys are there. 5 by 2. 2 operations can be done. Means 4 plus 2, 6 will be the answer. Why only 2 operations can be done? See, in the first operation, this will happen, na? These 2 elements will get killed and our 4 will become 5. And then 5 with these 2 elements, right? So can you see two elements getting killed? That's why whatever is the left length by 2, this 5 will then become 6, and in the end this one will be remaining here and this one will be remaining here, but it will not matter because our current ith guy has become the middle guy. So now it will be max of 1 plus 1 comma 6 comma 1 plus 1. So guys, the solution is simple. Any index I, try to make it the last man standing. Like this guy should not die till the end. Then what would be the best answer? Do it for each index I. And the problem is solved. You might say that, sir, what is the guarantee that even after doing these operations, the index I is only the last man standing? What if we assume that all the elements on the left and right are smaller than us? Okay, but there can be, bad cases also, but you don't need to worry about the bad cases. What if there was 100 here? Or let's say our index I is something interesting. By the way, this is our index I. We want to make this the last man standing, but I plus 1 and I plus 2, this is 100, this is 500, and like this. So you might think that, sir, if I do the operation of, let's say these are the right elements, I select these 2 elements with this, so they will win. I will not win, sir. Then also assume that you are only winning. Why? Because even if I plus 1 is winning, you don't need to consider it. Why? Because I plus 1's chance will also come. You will also try to make I plus 1 as a winner someday, right? That time the best answer for it will be considered. So you don't bother about it. And the best answer of it will be bigger than the best answer for 4 for sure. So guys, the trick literally is that just assume that you want to make your ith guy the largest as possible. Assume all the good conditions for yourself. Okay? And from the left hand side, right hand side, L by 2, R by 2. L by 2 plus R by 2 plus P of I is the largest possible value for the ith element. If everything goes well, you do it for all the elements and your job is done, done, and that's how the problem gets solved. So it's, even when we are considering the wrong cases at multiple indices, still the final answer will be correct because we will be going through the largest number also, na? So we can never fail in this technique. That's why I love it so much, man. It's a very tricky and nice problem. So you can see here that what we are doing is that we are taking the input of these values like this. You can also see it and feel it. Left is this, right is this, left by 2, right by 2, and d plus b will be the max, and take the max and done. Okay. Now let's go through the second problem, which is again very interesting, guys. The second problem is very interesting. Okay, like let me open it up for you people. Yeah, this is very interesting problem, guys. Trust me. Like, shall we play a game? Obviously, man. So, guys, Alice and Bob are playing a game. Okay, the starting number is 0. First, Alice, see, the starting number is 0. First, Alice will take the turn, then Bob will take the turn, then Alice will take the turn, then Bob will take the turn, then Alice will take the turn, then Bob will take the turn. Done. So what they are saying is that in each turn you can either do plus or minus 2 raised to 0 in the I think in the 0th turn. Then on the first turn, Bob can either do plus or minus 2 raised to 1. Then on the second turn, Alice can do plus or minus 2 raised. You can see that these numbers will increase. Then Bob can do plus or minus 2 raised to 3. Then Alice can do plus or minus 2 raised to 4. Bob can do plus or minus 2 raised to 5. So if everything like this is happening, let's say n is equal to 6 is given. N equal to 6 means 1, 2, 3, 4, 5, 6. This procedure will happen. In this procedure, let's say x is the maximum value you got, and let's say y is the minimum value you got. You have to find x minus y. But this is game theory problem, beta ji. Alice will always try to make sure that x minus y decreases, and Bob will always try that x minus y increases. If both of them play their game optimally, what is gonna happen, beta ji? That's what they are asking. So guys, let's try to analyze it for small n, and the whole problem gets solved actually after that. If I take n equal to 1, so only allies can make the move, right? Initially the number is 0. You can do plus 2 raised to 0. What will happen? Initially the number was 0. If you do plus 2 raised to 0, what will happen? The minimum number is 0 and the maximum number in the procedure is 2 raised to 0, 1. So what is x minus y? The biggest number is 1, minimum number is 0, 1 minus 0, done, 1, ha 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 ha. So the thing is that 1 is the answer. Okay. Now someone might say, sir, why are you doing plus 2 raised to 0? You could have done minus 2 raised to 0. Yes, Brita ji, you can do that also. Then what will happen? 0 was one of the number achieved, and after doing minus 1, it will be minus 1. So now the maximum number is 0 and the minimum number is minus 1. So 0 minus minus 1 is still 1. So 1 is the answer for n equal to 1. So guys, what if n is equal to 2? Alice wants to minimize the difference, and Alice is doing it all right, beta. Let's say Li does plus 2 raised to 0. Okay. Now n is equal to 2. What will happen? Now n is equal to 2. What will happen, my lovely students? Think about it. So n is equal to 2. And because n is equal to 2, our life is great and life is awesome. So first move, let's say Li is just plus 2 raised to 0. We need to assume something, right? Now the range of numbers it looks like this. Initially it was 0 and after plus it is 0 to 1. Okay. So you can see that this is the minimum till now and this is the maximum. Now you only think what should Bob do? Bob want to increase the difference. This range, can you see? Bob wants to increase it. This min max range, Bob wants to increase it. So what can Bob do? If Bob does minus 2 raised to 1, what will happen? The current number is 1, right? So 1 minus 2 is what? 1 minus 2 is minus 1. So the range will be like this. Minus 1 came one time, then 0 came and 1 came. Okay. Because you did minus 2 raised to 1. But if Bob does instead plus 2 raised to 1, what will happen? The range will be like currently the value previously was 1. So 1 plus 2 raised to 1 is 3. 1 plus 2, 3. So guys, see, there are two possibilities. This range has what difference? This range is of length like minus 1, okay, 0, then 1. This range is of length 2. But this range is of length 3. Bob wants this. Bob will try for a larger range. So Bob will do plus 2 raised to 1. So it's clear to us that Bob will do plus 2 raised to 1. Okay. Okay, G. So it will be 0 to 3. Now Alice comes. Now you only think what is going to happen. Alice has two options. Either Alice can do minus 2 raised to 2 or it can do plus 2 raised to 2. If it does minus 2 raised to 2, na, Alice wants to decrease the range. So see what will happen. Minus 4, 3, minus 4, minus 1. So minus 1, 0, 3. And if it does plus 2 raised to 2, the range will increase. 3 plus 4, 7. Now the range size is 7. But if you take this one, the range size is 4. Alice wants smaller one. So this will not be preferred. Alice will do minus 2 raised to 2. Guys, like this, you can make examples of yourselves, okay? You come to know that Alice should do minus 2 raised to 2 at this point. And the range will be, minus 1, 0, then, like this, dun, 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 ha, ha, ha. Now, guys, if you see the pattern, now if you analyze, you will come to know Bob also should do minus 2 raised to 3. You can see what happens, okay? You can see what happens because Bob wants to further increase the range. And then Alice after that should do plus 2 raised to 4. And then Bob should again do plus 2 raised to 5. So, guys, can you see the pattern? I want you to write this pattern by yourself in the paper. You will understand that first two moves should be positive moves, then two negative moves, then two positive moves. In this structure, whatever is the maximum value, na, and whatever is the minimum value, you get it done, and max minus min is the answer. So the problem is solved. So guys, this is the biggest observation that if both of them play optimally ना, समझो तुमको मैंने कोई n की वैल्यू दे दी, ठीक है? I give you n equal to 6. It means what? First plus 2 raised to 0 that should happen, then plus 2 raised to 1, then minus 2 raised to 2, then minus 2 raised to 3, then plus 2 raised to 4, then plus 2 raised to 5. This is what is going to happen in the 6-step procedure if both of them play optimally. But what is the max and min? So one thing is, guys, what you can just do a O of n loop, right? And you will get trapped. You might try to, add 2 raised to 0, 2 raised to 1, then subtract like this, and try to find max and min, and then do max minus min. Obviously, it is of n time complexity, but you can see n can be as big as 10 raised to 3. So, 2 raised to 1000, if you plus minus you do in the modulo, na, after doing modulo, you will not know what was actual max and actual min. So we need some proper way to either track max or min or get the max min by intuition. तो मैं क्या बोल रहा हूँ that don't try to find max min like this. You only think what could be the max. If this is the procedure going on, guys, what could be the max? Max will be nothing but the last, this full sum will be the maximum value. Why? Because the powers of 2 are going in increasing order, na? So the max value will always be the, like, if n is equal to 6, max value will be this. And what will be the min value? Min value will be the last time minus 2 raised to power was used. This will be the min value. 2 raised to 0 plus 2 raised to 1 minus 2 raised to 2 minus 2 raised to 3. So guys, what will be max minus min? Max minus mean is nothing but all these values are now subtracted and only 2 raised to 4 plus 2 raised to 5. So guys, for n equal to 6, the answer is 2 raised to 4 plus 2 raised to 5. So guys, like this now, for different n divisible by 4, you can find the trick, okay? So see, n is equal to 6 is nothing but what? When you do mod 4, what you get? When you do mod 4, you get, first of all, whenever n equal to 6 is given, you will first convert it to 5, right? Minus 1 you will do. Now, what is 5 mod 4? 5 mod 4 is 1. So, if let's say I is 5 and 5 mod 4 is equal to 1, then the answer was 2 raised to 4 plus 2 raised to 5, which is 2 raised to I minus 1 plus 2 raised to I. Okay. Now, what if n was equal to 5? You would do minus 1, it would become 4, right? So 2 raised plus 2 raised to 0 plus 2 raised to 1 minus 2 raised to 2 minus 2 raised to 3 plus 2 raised to 4. What would be the maximum value in this case? You can also feel it, right? It would be this full value. So maximum would be 2 raised to 0 plus 2 raised to 1 minus 2 raised to 2 minus 2 raised to 3 plus 2 raised to 4. And the minimum would be what? Everything till the negative number, right? So 2 raised to 0 plus 2 raised to 1 minus 2 raised to 2 minus 2 raised to 3. You should know that 2 raised to n is strictly always greater than 2 raised to 0 plus till 2 raised to n minus 1. Because of this, we can easily know when this is the minimum value. Okay. So if you subtract this minus this, only 2 raised to 4 will be remaining, right? So if this is your I, if mod 4 is equal to 0, the answer is just 2 raised to 4, which is 2 raised to I. So guys, if you do any I mod 4, only 3 values are possible: 0, 1, 2 or 3. If it is 0, the answer is 2 raised to I. If it is 1, the answer is 2 raised to I minus 1 plus 2 raised to I. Like this, you find the pattern for 2 and 3 and the job is done. So in their respective turn, they can either do plus 2 raised to I or minus 2 raised to I to the current sum. I is the ith turn happening. In this whole procedure, x is equal to max value achieved and y is mean value achieved. So x minus y allies optimally placed to decrease x minus y and Bob plays optimally to maximize x minus y. Best optimal method to follow is, you can see, plus 2 times, then minus 2 times, then plus 2 times, like this till the nth time. Can you see the pattern? And that pattern is the solution, baby. So hopefully you guys liked it and enjoyed it. Okay, you can see, first you do I minus 1. If this mod 4 is 0, then 2 raised to I is the answer, or 2 raised to I minus 1 plus 2 raised to I. You know this, you got it right, yeah. You might be thinking, I have calculated all the 2 raised to I in this power pre-calculation. Power of I tells me 2 raised to I modulo value. So this is a smart trick. Don't try to travel. Like many people will think, sir, इतना मेहनत क्यों करना सर, चुपचाप 1 से लेके n travel करेंगे और प्लस माइनस करते जाएंगे, मैक्स मिन का ट्रैक, दैट्स नॉट करेक्ट. यू कैनॉट कीप द ट्रैक ऑफ मैक्स एंड मिन, because when the value gets negative, na, this modulo thing ruins everything. Okay, so you better be safe. You better simulate what happens after max minus min and the answer rather than doing the actual procedure. So this is a tricky problem. Okay, let's go to the third problem. Now this is also hell tricky, but still you can get it done. Huh, easy, right? So guys, they're saying that, hey bro, just construct two strings, and none of the adjacent characters in both the strings should be same, and the LCS of both the strings should be k. You can use a or b or c. Okay, g. So guys, they are saying that I will give you some n and I'll give you some k. Let's say I give you n equal to 1, k equal to 0. Create two strings of length 1. You can use a or b or c in any of the strings. Create two strings of length 1 such that none of the character is matching. So you can say, sir, my first string will be b and the second string will also be b. This is wrong. None of the characters should match. B is matching with b, so that's not allowed. Yeah, you can say that the first string is a and the second string is b. The first string is a, second string is b. Okay. So if you have read this problem nicely, you must be knowing that for n equal to 1, k equal to 0, the answer is always possible. But if k is equal to 0, if they are saying in the question that k equal to 0 and n is greater than equal to 2, answer is never possible. Why? Like you must have read the question, you must be knowing what's happening. Guys, can you create any string of two length? First string also of two length and second string also of two length such that none of the character is matching. You might think, sir, here I will put AA, here I will put BB. Sir, none of the character is matching. The longest common subsequence is the 0 in both of them, sir. But one more condition needs to satisfy. Adjacent character should also not match. So AABB is wrong. A is matching with A, B is matching with B. So what will you do? You might think that, okay, sir, adjacent should not match. Now, so after A, I put here B. And for the second one, I will put here C. And then I will put A or I will put B. But then also you are trapped. One character gets matching in both of them. So guys, if K is 0 and they are telling you to make two strings of length 2 such that none of the adjacent character is matching, and also the longest common subsequence, the common characters in both of them should also be 0. This is not possible with ABC. So it's not possible for n equal to 2, n equal to 3 or any n except n equal to 1. So k equal to 0, n greater than equal to minus 1. So these many cases we have solved. Let's try to see the other cases, baby. Listen to me, baby. Listen. I really love you very deeply. Very deeply. Okay. So now, let's think what to do next. Okay. Life is very interesting and you should be very focused on your life. Okay. So, lovely student, let's say n is equal to 10, k equal to 7. So, do you understand? You have to create two strings. Two strings you have to create. How many strings? Two strings you have to create. And in both the strings, you have to make sure seven characters are matching. So, what is the first instinct which comes in your brain? And the three characters should not match. So, guys, this is the common sense. Huh? First string, second string. So, seven characters should match, right? So, A, 1, 2, 3, 4, 5, 6, 7. Here also A. So guys, K equal to 7 is satisfied in both of them. But guys, more than 7 characters should not match. So what will you do here? Here I will write B, C. So see, both of them are of length 10 and only 7 characters are matching. Okay. Everything is solved. Now guys, you must be thinking, but sir, adjacent characters are equal. How can I get rid of that? Well, you can put B in the middle. Okay. So if I put B in the middle, see, the strings will now look like this. You start putting B in the middle. So you will see A, then B, then A, then one more B, like put the B at the odd place, even place, odd places. A, B. Okay, so 3 times A I have written. Fourth time, fifth time, sixth time, seventh time. Okay. Same goes for this. A. So guys, almost this problem has been solved. See, both are of length 10 and still only 7 characters are matching. Why 7 are matching for the longest common subsequence? Because only A is common in all of them. I am not trying to put C both, so or else the longest common subsequence will increase. So दोनों स्ट्रिंग को देखोगे ना तो दोनों में 7 ही कैरेक्टर मैच हो रहे। देखो 1 2 3 4 5 6 7 बार ए, इधर भी 7 बार ए, बाकी बी और सी तो मैच नहीं होता ना एक दूसरे से। Everything is solved, guys. In both these strings, you got the technique. Whatever they are saying, na k equal to 7. Put the 7 A's here, 7 A's here, and then for the first string, rest of the characters B, and the second string, rest of the characters C. These 7 are matching, but you don't want the adjacent same, so you will put this B at the odd places as much as you can. But still, the problem is there. These 4 A's are together. These 4 A's are together. This is haunting you. What can you do for this? The trick is, the lovely trick is, my lovely student, the trick is that you will just, you will just cut it out, guys. Cut it out. Okay. Like the adjacent characters, I will just put a B here. And here also, I will just put a B here. And here also, I will just put a B. And guys, still the longest common subsequence is 7 only. Why? Because A, B is still matching A, B. So the 4 characters are getting matched from here. And this much part is giving rise to 3 matching characters. Wow! And the LCS is 7 only. LCS can never be more than 7. Why? Because this C will never match with the B of the first string. So guys, can you see? You do like this, and then whatever the rest of the equal characters are, you just put A B. So this will maintain this thing, and the earlier part will have only A as equal. So the full thing gets managed. Okay. But guys, this can only be managed as long as K is greater than equal to N by 2. If K is strictly less than N by 2, you can try to make the diagrams. This thing will not work out. Okay. Why this thing works out for K greater than equal to N by 2? Well, for k greater than equal to n by 2, na? For k greater than equal to n by 2, na? Here you can see k is greater than equal to, 5. It is guaranteed that the larger part, see, you can see 1, 2, 3, 4, 5, 6. This is the larger part, right? And this is the smaller part, right? Generally, it gets guaranteed that the larger part will always be of this fashion where AB and AC is coming. And the smaller part is where all the equal A's are coming. So if in the smaller part you do AB and on both the sides, the LCS does not get affected. But if you do it, but if let's say your K is 1, this trick will not work. You will just cry in hell, but the trick will not work. Let's say K is equal to 4. Let's say k is equal to 4. Basically, k is less than 5. Okay, see, n is 10, right? So if you take a k which is less than n by 2, you are screwed. Let's say k equal to 4. You want 4 characters matching, right? One, 2, 3, 4, like this. Okay. Then 6 will be b here, right? 1, 2, 3, 4, 5, 6. Then here, uh, C. You want the LCS to be 4, which is not possible. LCS of the strings will always be greater than equal to n by 2. Okay. You can see here the 4 are matching. Now you will use the trick, of alternating, right? Even if you alternate in the best way, B, A, B, A, B. Okay. B, A, B, A, B, A, B, A, B, A, B, A, B. 1, 2, 3, 4. 1, 2, 3, 4, 5. So still one more B is left here, right? 6, right? Same will happen for C A C A C A C A C A C C. Still it is not valid. See, you can see B and C are matching at both the places, right? The adjacent characters are matching. Now what will you do? Like, you will try to act as a smart ass, and you might try to say that, sir, what I will do is, sir, that currently the LCS of both of these strings is 4, because only 4 A's are matching with each other. But still it is not valid because this BB adjacent character same is coming. You might try to make this B as C, and here you might try to make this C as B, and then you are done. Your game is over. Why? Because now A, this B can be selected, and here A, and this B can be selected, and LCS will be 5. So guys, done. Problem solved. Okay. So shall we play a game? Always you should play a game. So guys, you can see if k equal to 0 and equal to 1, you can do something. K equal to n, both the strings should be exactly same, like, right? AB or ABC n times, like n by 3 times, whatever. You can do this. Then calculate n by 2. If k is greater than equal to n by 2, you know the alternating trick. But be careful, huh? Be careful. Like, I leave it up to the reader. You guys can be checking that one special case I have written, right? Yeah, that is a special case. Okay. If if your n is odd, na 5, then k greater than equal to n by 2 will work. Do you understand the meaning of this? 5 by 2 is actually 2, so k greater than equal to 2 will work. But in this case, now 2 is actually less than 2.5, but still it will work. Okay, for odd n's you need to be careful. So for odd n, na, when this difference does not get 0, this is a special case. You can check it out, guys. And guys, if k is greater than less than n by 2, then no answer possible, and done. Now let's check the fourth problem, lovely students. Guys, this is a very hard problem on dynamic programming and combinatorics. Now you should watch the video only if you have read this question 10 times and you have tried this problem 1,000 times at least for 1 hour. Not 1,000 times actually, but at least you should have tried this problem for 1 hour. Okay. So you have tried this problem for 1 hour. You watched all my prerequisite videos. I am now directly coming to this problem. Okay. I will not try to explain the meaning of this problem because this is for advanced people. The beginners can now stop watching the video. Okay. So guys, the counting problem says is that, that just try to count and tell me how many strictly increasing sequences are there in the array. How many strictly increasing sequences are there in the array? Well, this is a very standard problem, right? I give you any array, you have to tell me how many strictly increasing sequences are there. So for any index I, what can you calculate? dpij you can calculate, right? What will be dpij? Well, dpij will be nothing but the, strictly increasing sequences, strictly increasing valid sequences which end at index I, which end at index I, which end at index I, but their last value is j. Last value is j, guys. Last value is j. So this is very simple to calculate, right? you can pick up any other index I1, and then dpij if first of all this is the B array, and the ith element is j, it is guaranteed, and you come to know that B of I1 is strictly less than B of I. Then you can just say that dpij is nothing but dpij plus dp uh, I1, and here the number here would be j1, right? Let's assume that j1 is nothing but b of I1. So that's it, guys. The number of strictly increasing sequences ending at index I and the last number is j is nothing but the number of strictly increasing sequences ending at index I1 and having their value as j1, and we know that j1 or b of I1 is strictly less than b of I, then only the strictly increasing sequences can be made, right? So you can calculate this, like in O of n cube you can do this job, and using prefix sum dp you can optimize it to O of n square. Okay, so basically मेरे कहने का मतलब आप लोग समझ ही गए होंगे. So this much prerequisite you should know, or you cannot tackle the actual problem. फट जाएगी actual problem में. So dpij, the basic prerequisite. Okay, dpij is nothing but what? Think over this problem. I will write it here also, that before we go ahead, na, dpij is nothing but strictly increasing sequence in normal array without any minus one. Guys, strictly increasing sequences in normal array without any minus one, which end at index I, and the last number of those strictly increasing sequences is b of I, is j equal to b of I. Okay, so guys, like I will try to show you something. Okay, so what will be dpi of I? dpi of I means all the sequences which are strictly increasing and the last number is 5. So one is what? Only take 5 as the sequence, right? Only take 5 as the sequence, right? Another option is what? 3 comma 5, right? 3 comma 5. And I will give you the basic code for this technique also. Okay, that dpij strictly increasing sequences in normal array without any minus one, which ended index I and the last number of the strictly increasing sequence j. Okay, so 3 comma 5. Another one is what? 2 comma 5. These are the only sequences. Nah, one more. 2 comma 3 comma 5. So 5, then 3 comma 5, then 2 comma 5, then 2 comma 3. Total 4 sequences are there. Can you understand? dpi5 means strictly increasing sequences. 2 3 5 5 3 5 2 5. They are strictly increasing, and they end at index I and their last number is 5. Done, done. So you understand the dpij concept. But guys, their question is very difficult. They are saying that at any place we can put a minus one in the array. So don't take stress, relax, lovely students, relax. At any place they can give you minus one in your freaking array. And minus one means you can replace that index by any number from 1 to k. By doing this, many different arrays will get generated. Find the sum of f of a over all the arrays which can be generated. So let's say they have given you k equal to 2 and your array is this, n equal to 2. Your array is this. Now what is the answer? How many arrays can be generated? Here you can put any number from 1 to 2, right? 1 to k. Here also you can put any number from 1 to 2. So four different arrays can be generated, which is one, which is 1 comma 2, 1 comma 1, 2 comma 2, many arrays can be generated, guys. 1 comma 1, 1 comma 2, 2 comma 1, and 2 comma 2, right? So in all these arrays, what is going to happen? You are just going to chill and enjoy in your life, okay? So, well, what's going to happen is that for each of the array, you now find out how many strictly increasing sequences are there. Here, one is a strictly increasing sequence. This one is, there are two strictly increasing sequences here. Here, one and two, but one, two is also strictly increasing. Here, three strictly increasing sequences are there. Here again, two are there. Here again, two are there. So, 2 plus total 9 is the answer. So, guys, you have to first see how many arrays can be generated. For each array, you have to find the increasing sequence and add the final answer and tell. This is so complicated, my goodness. By the way, you know that it will be inefficient. It will be inefficient to generate all possible arrays, because there can be, if all the numbers are -1, there are k possibilities for each one of them, right? And the arrays of size n. So k raised to n arrays are possible. And for each of the k raised to n array, if you do run the n square dp, the time complexity will be n square into k raised to n, which is very big. N square is the efficient dp. You can do n cube k raised to n also. That's not good, beta. So we need to optimize it. So guys, after lots of thinking, you will come to know that the core concept here you need is LIS concept, longest increasing subsequence concept, which I have taught very nicely in our 850-hour course, and 15 to 35, OACP hard level problems and their variations are taught with detailed videos. If you have done them, this problem is a piece of cake for you. I'm not lying, it's true. So make sure, if you are not, you join our program training.desigana.in. Okay, you can just check it out here. Become ultra strong like my students. So guys, the first trick is that DP single IJ should be clear. DP single IJ means number of valid single length sequences which can end with the number j ending at index I. Okay, so this solves the whole problem. Let's say at index I the number is 5. So what will be DP single of I of 5? Means how many sequences are possible where only a single 5 is there, if you consider all possible arrays. And let's say k equal to 10. You might think, sir, only one possible sequence 5 is there. No, 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 no. How many arrays can be created? Here there are 10 options. Here you can put any number from 1 to 10, right? And here also there are 10 options. Here also you can put any number from 1 to 10, right? So 10 into 10, 100 arrays are possible. In all those 100 arrays, if you pick up this single number 5, so this 5 can come 100 times. Guys, they have always said that you have to consider all different arrays. So if you consider all different arrays possible, this single sequence of number 5 situated at index I, the DP single I5 का मतलब मालूम है क्या है? DP single I5 का मतलब ये है कि अगर सारे इस दुनिया में जितने भी एरे पॉसिबल थे 100 के 100, अगर सबको लिया जाता, तो एक सिंगल इंडेक्स आई पे 5 आने का कैसे कितनी बार आ सकता है? तो 100 बार आ सकता है. 5 can come at index I not one time, 100 times, because 100 different arrays can be created by each -1. So guys, the answer is nothing but you need to find out how many -1s are here. k raised to g1. G1 is the number of minus ones on the left hand sides, and k raised to g5, number of minus ones here. So answer is k raised to g1 dot k raised to g5, which is here the k is 10, k raised to 1 dot k raised to 1, which is k square, and 10 square is 100. So this single element phi, even this single strictly increasing sequence of length 1, strictly situated at index I, if you consider all the arrays, this guy will also at least come, at least one time it will come for sure. That's for sure. At least 100 times, like not at least 100 times, it will come exactly 100 times. Okay. So DP single IJ concept is clear, right? DP single IJ means number of valid single length sequences which end at number j and end at index I. It is guaranteed that B of I should be equal to j. Then only you can say na that at index I the number single length number is j, or the current I can be 1. Array, this could have been minus 1 also na. If this is minus 1, I will assume that I can put a 5 here. Then what would be the answer? Again, k raised to g1. Number of minus 1s on the left and number of minus 1s on the right. We will not consider minus 1 currently. Now guys, the second trick is you will calculate dp1ij, number of valid sequences which end with number j and end at index I only, but these sequences are only generated from all possible arrays of size 1 to I. So now guys starts the interesting procedure. You should be knowing the longest increasing sequence tricks, that whenever you're trying to find the number of longest increasing subsequences ending at index I, you try to find the second last guy from 1 to I1. Okay, 1 to I minus 1. Okay, so now let's say at index I have a 5. Okay, and even if there was a minus 1, you should be able to handle. You're a grown up now. This is only for advanced people who are watching this. So what would be dp, what would be dp1 I 5? All the strictly increasing sequences, all the strictly increasing sequences all the strictly increasing sequences which end at index I, and at the number at the ith index the ending number is 5. Which are those sequences? Well, those sequences can get birth by the second last element of the sequence. If the last element is 5, the second last need to be smaller than 5, right? So this will be nothing but dpi14. dpi14 means all the sequences which end at index I1, 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 and the number at index I1 is 4. All those sequences, when you join with 5, it will be a sequence like this, na, which is nothing but what? The valid sequences increasing ones ending at index I with number 5. So dp1i5 is nothing but dpi14. But I will multiply this thing with, let's say, k equal to 10. 10 square. Why did I multiply it with 10 square? Pause the video and think about it. 10 square. Why? Because dpi14 was telling me all possible increasing sequences which end at index I1 and the ending value is 4, but these sequences have been generated by all possible arrays from 1 to I1. Guys, all possible arrays have been created. समझ रहे हो मतलब? ये जो ये read the definition again, okay? dp1 dp अच्छा, always we write dp1, हाँ, dp1. dp1 ij is not just the valid sequences which end with number j and at number index I. Na. These sequences are generated from all possible arrays of size I. Okay. So dp1 i14 का मतलब वो सारे सीक्वेंसेस जो सारी चीजें फॉलो करते हैं, इंक्रीजिंग भी है, i1 पे भी एंड होते हैं, लास्ट का नंबर 4 है, बट यहां पर जितने भी एरे जनरेट हो सकते थे ना वो सब कंसीडर किए गए हैं. मतलब 1,4 भी कंसीडर किया गया, 2,4 भी कंसीडर किया गया, 10,4 तक सब कंसीडर किया गया. इन सबको कंसीडर करने के बाद जो लॉन्गेस्ट इंक्रीजिंग सीक्वेंसेस आ रहे हैं, जो 4 पे एंड हो रहे हैं i1 इंडेक्स पे, उनकी वैल्यू है dp1 i14. dp1 i14 means all the strictly increasing sequences ending at index i1 with the number 4, but it is guaranteed that all the arrays were generated from 1 to i1, like 1, 4, 2, 4 till 10, 4, and from them we found the valid sequences, added them all up, and that's the value of dp1 i14. But guys, we have not generated the arrays of this part now. Now these sequences will be multiplied by, see, here 10 possibilities can come, here 10 can come. So total 100 more arrays, whatever the sequences are getting generated from this part now, they can be put in 100 more arrays with the same 5 here. So whatever is this middle part now, for this middle part you need to multiply the 10 square value and get this shit, like get this thing done. So guys, like this you will try for each index, right? See, dp1i5 is nothing but dp1i5 is nothing but dp114 into k raised to g1, where g1 is the number of count of -1. Always remember what will be, this is nothing but k raised to g1. K is given, g1 is nothing but frequency of -1 in the range i1 plus 1 till i-1. ये जो बीच के रेंज में कितने -1 उससे मल्टीप्लाई कर देना है. Okay, so guys, like this we have to iterate through all the i1s na. So i1 can be 1 also, i1 can be 2 also, the 4 can be anywhere. So dp14 into k raised to g1 plus dp124 into k raised to g2 plus dp134 till dp1 I minus 1 4 into k raised to g I minus 1, something like that. But guys, we have only iterated through the cases where the second last element is 4, but the second last element of the strictly increasing sequences can be 3 also now, because last is 5. So 4 3 2 1, like this the full value will come. You can, this is currently O of n cube dp, you can make it n square dp by prefix sum dp. So I assume only advanced people are watching this and they understand how to optimize this n cube dp to n square dp. So guys, finally, you must be thinking, sir, the whole problem is solved, right? For each index I, we have successfully calculated something for each index I. What have we calculated? Even for index n, let's say this is b of n, dp1 n and b of n here, right? Something like that. Or b of h also you can write. But guys, is that like, what is this giving you? This is telling you all strictly increasing sequences ending at this index, okay, no problem with that, only if the arrays from here to here are generated, from 1 to I are generated. This is not enough now. You need to know all the strictly increasing sequences ending at index I if the full arrays were generated. So now you will write dp2i5. You can see what a chilling problem this is. dp2i5 means all the strictly increasing sequences ending at index I, the last number is 5, but these sequences have been generated by generating all different arrays from 1 to n, even though you are at index I. This is nothing but what? dp1i5. This is dp1i5 means this much part is solved, multiplied by k raised to y, where y is the number of -1 in this part, because these different arrays will also get generated now. and these will be multiplied with these sequences. So my goodness. Oh ho ho. Shit, man, shit. This is really thought provoking. So, number of valid sequences which end with number j and at index I, but these sequences get generated by the arrays of size 1 to n. Basically, here you are now sure that all the arrays of size 1 to n were generated, and then what would be the answer? So, the number of minus 1 in the range I plus 1 to n you should know, which you can easily maintain. You are, must be advanced person. So, what will be the final answer? The final answer will be nothing but the summation. Okay, matlab all the sequences generated by all the arrays which end at index 1 with the value of 1 plus all the strictly increasing, this was also all the strictly increasing sequences generated by all the arrays of all the types at index 1 with the value 1. But it can happen now that at index 1 something might be ending with value 2, so like this till the max k value, assuming that b of I is equal to minus 1, this with till the index n this thing can keep on happening, right? dp2 n 1 dp2, all the strictly increasing sequences they can end at any index ending at n, having their final value as 2, but we assume that we have generated all the arrays to reach this point. Okay, and here dp2 dp2 of all the sequences ending at 2 and then 1, like this is just interesting stuff. Like this till the end and the job is done. So hopefully you guys enjoyed this session. Ram ram.